Series in Python are built on top of the NumPy arrays by adding labels to index positions. A series is a 1D array and can hold any type of data, namely strings, integers, floats, dictionaries, lists, booleans, and much more, even built-in Python functions. It can be imagined as a single column from an Excel table. So let's start by importing libraries first. We'll import NumPy and pandas for today. Now next, we will create a series from different types of objects. We will create from a list, both string and integer, then an array, and from a dictionary. So let's create these objects first. Let's create a list for labels. We'll call it labels. It's a simple list of strings A, B, C. Now next, let's create a list of integers. And then we will create an array. We'll call this ARR. We can use np.array for this and pass in our list through this, and it will create an array for this list. And finally, we will create another object for dictionary, and we will use key value pairs here. Let's our keys be A, B, C, and values should be 10, 20, and 30. Let's check this one by one. We have our labels list, my list, then our array, it's an one-dimensional array, and then our dictionary. Now next we have to create a series. Let's create one from the first object, which is labels. So we have to write pd.series. As you start typing, press tab, it will autocomplete, and then pass in your labels. So what it did here was it created a series of the elements of the list labels, which was A, B, and C, and it also added an index to it, which is 0, 1, and 2. Now let's see a series for the integers. We can pass in my list. Now it created a series for the elements of this list, my list, which were integers 10, 20, and 30, and it has once again attached the index to it 0, 1, and 2. Similarly, we can create the series for an array as well. We created this array using the same list, so the elements are same, 10, 20, and 30. This is just to show that an array can be used to create a series as well. Next, we can create a series using the dictionaries as well. For the dictionary, all of these values 10, 20, and 30 will be created as values for the series, and the keys A, B, and C would be used as an index. Now let's check this further. When we type pd.series, press shift tab and check the docstring for this. So here we have quite a few parameters given here. First one, which we have to pass, is data, which we passed above. Then we have second option given for index as well, and then we have data type, name, and copy. We don't need that right now. So let's see. We pass in our data as my underscore list, and it returned a list. It returned a series with elements 10, 20, 30, and it attach an index 0, 1, 2 with that. Now if you want to give a specific labels to this, we can use the index parameter, and let's use our labels list for this index. So what we got now is, for our elements 10, 20 and 30, we have a label index here, A, B and C. So this is our customized list. If you want to see another one, we can also pass in the data of built-in Python functions. So let's pass in a list here of sum. This is a built-in Python function for sum. Then we have print, then we have len for length. See, this will return a series with built-in functions. So this just goes to show that a pandas series or a Python series can store any type of data. It can store built-in functions, dictionary, list, strings or integers. Now the key to using a series is understanding its index. Pandas makes use of these index names or numbers by allowing for fast lookups of information. So let's see some examples of how to grab information from a series. Let's create a series called sir1. This is a variable and we will create a series. The data we will pass in here would be a list of integers, and now we want an index here as well, and for index we will pass in A, B, C, D as labels. So let's check this. So we have our series here with label index. Now let's say you want to grab this element 1 here. So you can do that using the Python series indexing. Within square brackets, pass in the label index and it will return you the corresponding element for that label, for that index. Let's try another one. Let's say you want to grab multiple elements from the series. You can pass in a list here. Let's see, we want B and C. Then it will return you a series with only those corresponding index. Now let's check for some basic operations in series. We will create another variable here for series 2. We'll pass in another list. Here we will change one element and we'll pass in the elements for the an index level. So here we have one change from the series 1 we created above. In place of 3 we have 5 and the label is called E. So with this, once again, if you want to index this, you can do it the same way. Now let's say we want to add both series 1 and 2. We can use simple arithmetic operations on the series. So see, what this returns is sum of two series where the index is available in both of those series. However, if the index is missing in any one of the series, in that case it returns a null. So for example, for A, we had 1 in both series 1 and series 2, so it added the elements for index A and returned a 2. Similarly, for index B, it added 2 from both series and returned 4. C was available only in series 1 but not in series 2, so it returned a null here. Similarly, null for E because it was available only in series 2. For the index D was available in both, was present in both series 1 and 2 with value 4, so it added both of those to be 8. Now remember, just because the index is same, the value doesn't have to be same. it could have been different, could have been 5 and 4, it could have been 14 and 40, and in that case it would have returned 54. Similarly, you can carry out other arithmetic operations like subtraction, multiplication, division for the series as well. You can also uh, use scalar operations with this series. Let's say we have series 1, multiply each element by 2. So it will return that series 1 with each element multiplied by 2. Now next, let's move on to the data frames. Data frames can be thought of as a bunch of series objects put together to share the same index. It is a two-dimensional constructed with rows and columns and designed to handle tabular data. It's similar to an Excel sheet and is the main way we store or handle data in Python for data analysis and data science. Generally, data would be imported into a data frame in Python from an Excel sheet, CSV file, HTMLs, etc. Here, we will drop a seed for random number. This is if you are following me and practicing this as well, you would get the same random numbers as I would get. So what you can do for that is np.random.seed and let's drop 101. Now we will build a data frame from scratch. As I said earlier, in real world we would be importing data from some data source. We would never be building data ourselves. But since this is for understanding, this is to learn Python, we will build a data frame from scratch here. To build a data frame, we will write pd.dataframe, start typing, press tab, D would be capital, and then check the doc string. So to build a data frame, write pd.dataframe, D would be capital, and check the doc string. We need a data parameter, an index, and a column here. So for data, we will generate some random numbers, np.random.randn. Randn is used to generate random numbers based on a standard normal distribution. Standard normal distribution will have a mean of 0 and variance of 1. Make it an array of 5 by 4. Then we need to pass in the index for this. Here we can use a list. A, B, C, D, E, because there will be 5 rows and we need to put in columns as well. There will be 4 columns. So let's check this. So you see, this is very similar to a table in Excel. It has the column names and it has the row names, and it has values for each of the cell in between. Now next, how do we select or index the columns from this data frame? So we can index it once again using the column names. So let's say we index the column W. So this will return a series of just the column W and all of the rows index as its index. If you check the type here, this is a series. Let's say you want to now index multiple columns. Well, you can do that using a list of the columns you want. Let's say I want to index column W and column Y. Pass in a list and this will return another data frame with the columns W and Y in that. If you check the type here, this is now a data frame compared to the series we got when we index just one column. Now creating a new column. To create a new column, we can just define it as if the column already exists, and we can use the existing columns to fill in the values for this new column. Let's say for this new column we want values of sums of W and Y column. So let's check the data frame. As you can see, now we have a new column here, and the values of that column is the sum of the values in column W and Y for each index, each row index. Now next, how can we remove a column from a data frame? So we have our df data frame. To remove it, we can use the method drop. Just pass in the name of the column, and this will return an error here. Let's check the error. What this says is new not found in axis. So what this is returning is that column new does not exist in that axis. If you check the docstring, we have a parameter for labels which we pass as new, and then we have a parameter for axis which is given as 0 by default. Now 0 denotes row index. For column, we need axis is equal to 1. Pass this, and now that new column has been dropped here. However, if you check again, check this data frame again, and you will see that new column is there. So why did this happen? Well, to protect us from dropping rows or columns by mistake, what Python has another parameter here which is called in place, which is by default given as false. So if you want to make the changes as permanent, you need to turn this parameter into true. Select in place, true. And now if you check our df, you will see it has been dropped permanently. We can also drop rows from this data frame. Let's say we want to drop row E. Here remember we have to pass in the axis, but it is given as 0 by default. This axis is given as 0 by default, so we don't really need to include it while dropping rows. However, if you want to drop columns, you would have to turn this into 1. Also, we have index and columns given here, so if you don't pass in the labels, if you define those as index and column, then you won't need to use this axis parameter here. So let's use this for to drop row E, and see row E has been dropped, but this is not in place. So if you check df again, row E would be there. Now we will move into selecting and indexing rows. We cannot directly index a row from a data frame. To use that, we have a couple of methods available for us. One is .loc method, which is sort for location. Use this method and then pass in your row index, and this will return you another series for this with the data in the row A, and the column names would become the index of the series here. If you check the type, this is a pandas.core.series.series here. The other method you can use here is iloc, and that is for indexing. So you can, rather than using these labels, you can select the index here directly. So let's say I want to drop this C column. Well, this is at index 0, 1, 2, and here it will return a series for this C row here, which is at index 2, with the column names as its index labels. Now what if we want to select a particular column here as well along with the row. Well, we can do that. Let's check our data frame. Let's see, we want to select this value here. This is at row B and column Y. This is at row B and column Y. So to select that, we can use .loc, select column B, and then there are two ways. Either we can select this and then index it again as a series for index Y, and we will get our value. But a more logical way of doing this is, here you can use the comma and then put column index there as well, and it will return the same answer. Now let's say we want to select a portion of this table. Let's say we want row A and B and columns W and X. So to do that, first we need to select this rows, and we can pass in a list for that. And let's say for the columns we want to select W and Y, not W and X, because I want to show you that we can select non-continuous rows and columns as well. So for this row as well, we will turn this into A and C. So we want to select this value, then this value and this value. So for rows A and C, we can pass in a list here, and then there would be a comma, and then we can pass in a list for columns W and Y. And see, this will return. If you check the data frame once again, we have our 2.7, 0.9, minus 2.018 and 0.52. If you want to select continuous rows and columns, we can just use slice index here. So A slice, let's say we want to select till C, A colon C, it will select A, B and C, then comma, and now we have to select column. You can either pass in a single column as a string or a list of columns for multiple columns, or we can use slice index as well. So see, this will pass rows A, B and C for columns W and X. So we will expand further on this data frames in our next video. Until then, thanks for watching. See ya.